Yeah, welcome back to Object-Oriented Programming 1. We will now have a look at the second part of classes. So we're still, second week. Everything about classes, or at least the first steps, are covered in this week. Next week, we will talk about inheritance, also polymorphism and exceptions, and then some advanced topics after that. Yeah, let's start with a very brief recap of classes, so what we have done in the last 1.5 hours. You won't need the slider code at the moment, so we'll just have a look at this code snippet here. So what have we learned? We have learned that a class has some members, some member variables, and they should always be private. So we have a private region and we have a public region. These regions, or these keywords, are called access specifier, and with these access specifiers, we can define what should be visible from outside the class and what shouldn't. We have also learned what is a constructor. We've learned what is a constructor without any arguments, so what is the default constructor in this case, and we have also learned what is a constructor with arguments, and that we can also use an initialization list. Yeah, when we have a constructor, we can also have a destructor, or always have a destructor. And the difference between the constructor and the destructor regarding the syntax is that we have the tilde symbol here in front of the destructor. So the constructor is called when we create an object, the destructor is called when an object is removed. And we've also learned about methods and two particular types of methods here, which are getter methods and setter methods, which realize the concept of encapsulation. In German, it's Verkapselung, which is one of the basic concepts of object-oriented programming. And now we want to continue with static. Static is, as const, just a keyword, but if we use this keyword static, for instance, for member variables, it will have a different behavior than member variables without the static keyword. If we define a member variable with the static keyword, this then means that all the objects will have the same value for this particular static member variable. So if we have a look at this code snippet here, we define or declare the static int number of wheels member variable here inside the class, and we then initialize it outside of the class, but this looks a bit strange. So we have the car class name here, and then, as we know it from namespaces, or enum classes even, we then use the scope resolution operator, so just the two colons here. And with this, we can then initialize static member variables of a class with using the double colon, so the scope resolution operator. And to now use this static member variable, we can just access it by the class name, and again, the scope resolution parameter here. And what is important about static attributes or static member variables is that there is only one instance of this attribute. So if we now remember pets have a different type, so we have cats, we have dogs, we have goats, whatever. So these member variables have a different value depending on the object. But the static member variable has only one value, and this value then applies to all objects that we have of this class.
So basically they all have a reference to the same variable.
Basically, yes. So let's take a look at static attributes in more depth with using objects. Again, we have this static member variable here, and we initialize it to 4. Now we have a main function where we actually create 2 different objects of the type of the class car. And if we now access this static member variable using the object, we will get, in both cases, 4 as an output. So, independent of the object that we create and then use to access this static member variable, we will always get the same value. So it's independent of the object. That's really important. But we cannot only have static member variables, we can also have static methods. So static methods are, as static member variables, again, the same for all objects that we create of a class. Again, we can call a static method using the class name, then the scope resolution operator here, and then just the function name. And same as for the static member variables, we cannot only use the name of the class to call it, but again, we can also use actual objects of the class that we've created. However, at least in my opinion, it's the preferred way, or my preferred way, to use the class name and then the scope resolution operator and then call the static method or access the static member variable.
Makes it more clear that it's really a static method, yeah.
And independent of objects. Okay, but what if we have a non-static member variable and we want to use, to access, to modify this non-static member variable inside of a static method? Well, this is not allowed, and the compiler will say you're not allowed to use people, which is a non-static member, inside of the static function, in this case the method display message. So this means static methods cannot access or refer to non-static member variables. This is not allowed. And why should we even use static methods? There are quite a lot of use cases, so it's really good if you have a general behavior that applies to all the objects of a class, that you define a static method for this, if this behavior should be the same for all objects, so if this is an object-independent behavior. Before we start with the quiz, are there any questions to static member variables, static methods? Yes?
Couldn't I also use a subclass, or is that different?
Can I use a subclass?
For what reason, or
Why
what do you want to achieve?
Something similar to static, that I have one object that is has some behavior, and I have other objects that as well inherit the behavior of the first object.
Yeah, you can do it. We will come to inheritance next week. You can do it, but static is a bit different because, for example, all the static members and also the function or the methods, they are only created once. So you actually have one variable, and if you have inheritance, you would have a new copy of it. So if there is, for example, the number of wheels of any car hopefully will be 4, it will make sense to make this static.
And I guess it's also more efficient in that.
Yeah, it's more efficient because I need less space.
Yes.
Does it matter in which order we put static void? So is void static different from static void?
So is the order of the keywords you mean important? As far as I know,
It's a good question.
I haven't tried to swap it.
I think there was something, but I cannot remember it. void
We'll check that shortly and then.
static. Let's do the quiz in the meantime.
Yep.
Yeah.
So, okay, we have a static member variable, number of wheels, and we then create two objects in the main function and modify the number of wheels variable for, or with the Ferrari object, set it to 4, and then we modify it again using the Mercedes object. And I've looked it up. There is actually a Mercedes that has 6 wheels. 6 wheels. So
Really? Okay, so we can forget about our static variable. Cool.
So let's wait a few more seconds. Let's say 10 seconds, and then we'll check.
Okay, so it doesn't make a difference to write static void or void static. Both works.
So most of you got it right. Perfect. It's actually 6 that is printed, even though we use the object Ferrari here to access the static member variable. But as we've said, static member variables are independent of objects. So as soon as we modify it in this line here, also any other objects, or if we access it directly using the class name, will have 6 as value for the number of wheels. So it doesn't matter if you use here Ferrari, if you use Mercedes, or if you access it using car and then the scope resolution operator. It will always be here the last modification that has been done.
So if we would initialize it in this line here, yes,
Yep.
it's pretty much the same. Yeah.
So it's really the last modification in this case here that affects the output.
There was also a question before. Yes. I waited for that question, to be honest. Can we initialize it also within the class? Not if you do it like this. The compiler will say it only works if it is const. So you have to create a static const variable. Then you can initialize it inside the class. Yes?
You'll be using that, or will you just use the constructors to initialize these stuff? What's the convention?
It depends on the use case, but I would say in most cases, doing it like this is the preferred way. Yeah.
I think there was also a question here. Was that? Yeah.
What is the line between the class and main tree? Why is that there, and what will happen if we remove it? What does it do?
You mean this line here? Yes. So here you actually define the static member variable of this class. Or declare it, sorry. You declare it. And then you can, if you have any modification here, so it's just one declaration. If that's... Yes. If we wouldn't do it here, that it wouldn't work, you mean? If it would work, yes, you can just access them or modify it here via the car object or class name.
Just tried it. In this case, we don't need it here. We just would need it if we want to set a value. You don't would need it in this case if you don't want to set a value. So it's a bit useless there, to be honest.
Yeah. In this case. But,
If I remove the assignment to 4 and 6, then the cout will be for the number of wheels will be
any random number. So if we do not initialize it, it's again with any other variables in C++. It's the same as in C. We don't know what's inside. Really? I tried it. Which compiler do you use? Because it works with me. A Clang++. Interesting. Interesting. Maybe we have a look at this later. I don't know maybe it's a version error or I'm missing something. Let's discuss that later on. But let's continue with the lecture. I think that's a very, very detailed question.
But yeah, important regarding static. You can have static members or attributes, and you can have static methods. Static attributes or members have the same value, so the variable has the same value for all objects of the class, so it's object independent, and you can access them via either class name, then the scope resolution operator, and the name of the member variable, or you can also do it via the object name. And it's basically the same for static methods. So a static method has the same behavior for all objects of a class. So it's again object independent, and you cannot access attributes of objects that are non-static. So you can only access attributes or members that are static in a static method, and again, you can access them via the class or the object. Any final questions to static before we continue?
Then let's
Great.
move on to a bit more interesting.
Yeah.
Just not only a keyword, but another type of constructor, the so-called copy constructor. So we have learned a lot about constructors, and they can have different parameters. And the copy constructor is again just one modification and one specific type of a constructor. Let's see what it is.
Yeah, let's start with a definition. So a copy constructor is a constructor which can be called with an argument of the same class type and copies the content of the argument without mutating the argument. So this means it's basically a constructor, but you pass an argument which has the same class type. So if we have a pet, we pass an argument of the class type pet, and then all the content of this passed pet is copied to the new pet without mutating the original pet. Again, quite confusing. We will have a few examples and have a deeper look into it. So when we have a look at this code here, we have some private members. We have the constructor, the default constructor here without any parameters, and an initialization list. Then we have another constructor which receives the string name and the string superpower. And most interesting in this code snippet is the last constructor, which is now called the copy constructor. So the argument that we pass is actually a const reference superhero s. So we pass a superhero to a constructor of the class superhero. Confusing? I totally understand this, but really important and really advantageous topic.
So
concept.
Maybe let's stop here. What's the argument once again? The argument is a const superhero, so the same type as the classes, superhero reference, and we just give this a name, a variable name. And then we initialize it with the values of this superhero we received as argument.
So we just use the member variables of the passed argument, so the name of this argument here and the superpower, and initialize the member variables of the object that is now created using the superhero in this case that was passed to the constructor. Yes? Sorry?
Would it work with a static variable? No, because you always need a specific object.
So
We will come to that in, I think, on the next slide. You always want to make a copy of one specific object and not from a static, from the whole class, for example, because you always want to copy an existing object into another new object and copy all the values from it. So maybe we can go to the next page.
just an addition here.
Yeah.
So you don't copy the class, but you copy one object into another object, or the content of an object to the contents of an
So
object.
the members
The members.
of one. So we create one superhero. We call the variable hero1, give it the name Superman, and the superpower is flight. And with this second line here, we call the copy constructor. I know it's difficult. Why should we use the copy constructor using like this? I don't have an explanation, to be honest, why with this. So I have an explanation, but we will come to that later on. The copy constructor is called when you assign an existing object and create a new object. So we have here an existing object, and we create a new object here and assign all the values from this hero1 to this hero2. So when we execute this line of code, the copy constructor gets called. We have here the hero1 as argument, and we are inside the hero2. So this name here is the name of my hero2. This s.name is the name of my hero1, and I copy the name of my hero1 into the name of the hero2, and the superpower of hero1 into the superpower of hero2, using the initialization list. Yes.
Does this answer your question? Perfect.
Why do we define the argument of the copy constructor to be const if our hero1 is not really a constant, or is it?
It's so we don't want to modify the hero1 here. Does not make sense if I want to make a copy to modify the original object. So again, it's good practice to define the object here, the object to copy as const.
So we don't want to mutate the argument, so the original object that is passed as argument. So that's why we use const here.
But it's a very good question. And this is maybe, I don't know what's coming, to be honest, but this is maybe one of the hardest slides for today, because you should get that here the copy constructor is called and what this means here. And if you have questions, please ask them now, because this is crucial to understand. Yes?
So if you don't define it, it's just an error, right?
If you have not created this copy constructor, and you mean then do it like this.
In other languages, it's just you just assign it and that's it.
Is there a default copy constructor? I think so.
There is
There is one, yeah.
Yeah.
There is a default copy constructor, but again, it's good practice to implement it because you don't really know what the default copy, so you have no control over the default copy constructor. And doing it like this, you can explicitly say, okay, the name should be set to the name and the superpower should be set to the superpower. And we will have classes with way more members in the future, and sometimes you have to do more than just copying it. So it really makes sense to implement the copy constructor as soon as you know you will create copies of it. Yes?
These curly brackets next to the constructors, I forgot, they are just a code block that should be executed as a constructor.
This
Yes.
one here.
Yeah. It's again just a function body, and you can do whatever you want to do there. For example, some printing to like having a debug when it is called, but basically you can execute code whatever you want there.
So yeah.
Sorry, this may be a weird question. Have you ever
I love weird questions.
done like a very specific copy constructor that does like very specific things when you copy it?
The question is, have you ever done very specific copy constructor? Yes, and I think you will also implement it in the assignment because when it comes to dynamic memory, and we will talk about that, you will need more than just copying some members. And what we didn't discuss until now is you also can have not only strings and integers as members, you also can have other class objects as members, and then you have to do again more work.
And thinking outside of this lecture here, maybe operating systems is an opportunity to work on fancy copy constructors. So yeah, there are some cases.
Sorry, maybe not relevant, but how does the compiler recognize that the constructor is a copy constructor if there is a default one?
That's a very good question. How does the compiler recognize that this is the copy constructor? By the name, the class name. So again, and then if you have one argument with the class, if it's an object of the same class, the compiler knows, okay, this is my copy constructor. Yes.
To relate to this question, so is it only then an object of the class? Does it have to be a reference? Does it have to be const? What about those parameters? But if you remove const, will it recognize it as a copy constructor?
You don't need to write const there. It will work also without const, but it's not good practice to do it without const. Without the reference, it will not work. There will be a compiler error.
In some cases, well, it will technically be used by the compiler as a copy constructor, but in order to call it, it needs another copy. So it either needs another copy constructor or a function that returns it.
Yeah, so it will not work if you just use it, not the reference. You need more work. Yeah. Okay, so we might confuse you even more because there are different ways when copy constructors are called. The first one we already saw, when you create a new object from an existing object using this equal sign. Yes?
Can you also initialize it with braces?
Yes, you can also initialize it with braces. Yeah.
Sure.
The second type is when you use call by value. We know it already from vectors. Vectors get copied if you don't use it as a reference. And also objects get copied when you don't use it as a reference. So when you call a function and you pass an object, then the object gets copied. So again, if you hand over objects, use references to avoid copies, because otherwise the copy constructor is called. And also if you return objects, It's again the same pretty much as the second point. A copy is returned, so the copy constructor is called.
Can you see this when you're debugging? Is it stepping inside the copy constructor?
Yes, it's stepping inside the copy constructor. So the easiest way maybe in the beginning is to just have a print inside the copy constructor, then you know when it's executed. But of course, if you're debugging, you will see that it's stepping inside, executing the code. Yes, we already answered this. Yes, there is a default copy constructor. No worries. But just one more thing to your question. In C++ or in general with object-oriented programming, it's not like C where we have only line by line and maybe a function call. We will jump more into classes. If there is a method call from the main, we will jump into a class, we will execute the code there, we will jump back. So it's not that one line after another in one function. We are jumping more around also in different files, where we'll come to that later.
Okay, we now have prepared an example here where we have the default constructor here, and we have a copy constructor. Again, it's const reference time t, which then assigns the member variables of the passed argument t to the member variables of the object that is now created. We also have a method here, syncTime. So we receive as an argument, again, a time object, and then, again, set the member variables according to the passed argument. And now let's have a look at it when which constructor is called. So when we create an object like this, the default constructor is called. We already know that. Now we can also create a new object and pass this object here, so the first object that has been created, as an argument to the constructor. And this is now the copy constructor, which is called. The same for this line. We know the syntax might be a bit misleading here. So it's not really an assignment, but it's really a copy that you create, in this case, from the object T1 to the object T3. And again here, this is the case David mentioned just before. If we pass an object to a function, to a method in this case, by value, then also the copy constructor is called. So when this statement is executed, this object here is then copied to this parameter or argument here. And in the copying process, the copy constructor is called.
The last one.
It's again a bit tricky. So as I said, this might be a bit misleading.
Because it's basically the same as the third one, but there's
almost
one difference. In this case, the left, so the T3 already exists. So we don't need a copy constructor because the object already exists. And there's something called the assignment operator, which is pretty much the same. We will talk about that when we talk about operators or operator overloading, I think in 3 weeks, something about like that.
So,
yes. Can there be more than one copy constructor? I cannot think of any.
Would it make sense to have multiple copy constructors?
Not really, no. I didn't get that one. No, so you cannot, as soon as you have an argument which is not time, It's not the copy constructor anymore. It's a usual normal constructor then. But to be a copy constructor, the argument has to be the same as the class type. In this case, time. So it always has to be a time reference, and then it's recognized as a copy constructor. If you would hand over in this line here, just like an integer, it's just a normal constructor. Yeah.
And you copy the whole code, those 5 lines. But in the second, the copy, you don't use hour, but just minute.
Okay, but then you have 2 copy constructors with the same signature, so the same name and the same argument, and you will get a compiler error. If you have 2 times the completely same constructor.
First one, you pass the hours, and the second one, the minutes, for example. If it was another data type, let's say integer and string, so that would be possible.
I'm not sure if I get it correctly, but
yeah. No, because it's only a copy constructor if you have, in this case, a time reference argument. As soon as you hand over another data type, it's not a copy constructor anymore. It's a usual constructor, just a normal constructor. It will work, you can have more, but copy constructor always or only works if the argument is of the same data type as the class is. Then it is a copy constructor.
Yes.
And if I would have one copy constructor where I only pass, for example, the time, the reference to the same object, and then I would have another copy constructor where, for example, I pass in 2 objects, and then I would, for example, add all the values of both of the objects together, for example. This would be a use case maybe to have a second copy constructor. Would you do this differently? Or?
How would you call this copy constructor?
Is it really a copy if you do not really copy the value of one object that is passed, but if you somehow manipulate these values and then assign it?
So you cannot really give arguments to this copy constructor here. But it's just the copy constructor is called at specific cases. But you cannot define arguments to this copy constructor because there is only one argument, and this one argument is the original, or let's say old object you want to copy. But you cannot add arguments to this call.
So I cannot add multiple, the constructor
Yeah.
is only if I add one object.
The copy constructor only works for one object, as argument, yes.
But you can, of course, have multiple different other constructors. But then it's not a copy constructor.
Yeah. Exactly, You can mix it, but it's not a copy constructor anymore. So you can have a constructor, maybe that's also the question from your side, I don't know. You can have a constructor having an integer for hours, an integer for minutes, and then a time object with 3 arguments. That would work, but it's not a copy constructor. You have to call it explicitly then, giving the 3 arguments, but not with these types here. So this will not call this constructor with the 3 arguments. This will always call this constructor with the 1 argument. Okay, now I got it.
This one here.
I already said it before. The right object, the T3, already exists. So we do not really need to create a new object. It already exists, but we are just assigning new values to the object. And that's why it's a bit different. It's a so-called assignment operator, and we have to work out on our own how this should be implemented, how this works. But we will figure that out when we talk about operator overloading.
So this line here is just an initialization,
Yeah.
and this is an assignment. So that's the difference, and this is also the reason why in this line the copy constructor is called, and in this case we will see the assignment operator.
I know it's very, very confusing.
Yeah.
Yeah.
If
Yep.
the T3 was another class, what would that happen? Would it also be like
If T3 is another class, so you want to create,
variable? So it's a different class.
yeah, so so it's not a time object, it's from any other class.
It's a date object, for instance.
Okay, you cannot assign a time object to anything else class. Yeah, you will get an error unless you have implemented it. You have not implemented it.
So
Yeah.
it's the same like integer and
Yeah.
Yeah.
But there are ways to do that. But again, we will come to that in a few lectures.
Okay, any other questions to the copy constructor before we conclude it with a quiz?
Yeah, let's make the quiz and let's see
Perfect.
how many got it.
Yeah. So we want to create a copy constructor for the class pet.
This should be doable now after
Yeah.
discussion of like half an hour.
So which of these copy constructors is a correct copy constructor for the class pet? Okay, let's wait 10 more seconds. And let us see. Yeah, great. 85% got it correct. So if we want to declare, or in this case define the copy constructor, we have to use the reference of the source. So this is really required, and it's also best practice to use the argument that is passed as const. Okay, I think we can
Yeah,
now
let's move on.
continue.
Also, in the interest of time, we should talk about dynamic memory in C. And I know this was very, very painful in C. Now we are talking about C++, of course. In C++, or in C, we have used malloc and free. We always had to check if the pointer is valid, and then we could modify it, and we have to free it in the end. In C++, there are new keywords, which is new and delete. Basically doing pretty much the same, but not really, a bit different behavior. So the new keyword gives us an object on the heap, or a pointer to an object on the heap. Similar to C, when we called malloc or calloc or realloc, and then we had to call free, we have to call delete here in C++. But compared to C, where we had to create or allocate just memory space, so we had this size of struct and so on, we can create here objects, and we do not have to specify the size because it's determined internally how big the memory size of the time object, for example, is. So I can create here a time object, I get a pointer, I can work with this, of course, and then I have to delete it in the end. What if there is no more memory? Very important questions in C. Again, C++ is easier in my opinion, because we do not need to check if new returns null. It will not return null. It will instead throws an exception we will talk about exceptions next time. We already talked about it at vectors, I think,
Yep.
a bit. But yeah, please be patient. We will talk about that. In the meantime, you don't have to worry about it because we have not learned it now. So new and delete are the new keywords for C++, and this is pretty similar or basically the same as in C. The difference between stack variables, so local variables, and variables on the heap is that they remain until you delete it, so you can create it inside a function or inside a method, and then you can also to return it, for example, and you can work with this object or whatever you returned until you delete it. Yes?
I know we're getting there at some point, but isn't using smart pointers even better?
Isn't using smart pointers better? Of course, using smart pointers is better. We have a dedicated lecture just about smart pointers, and then where we can use it. But from now on, let's stick to new and delete. But you, of course, you're right. Yes. Just to shortly mention, smart pointers is a very, very cool feature because you don't have to delete it. It will get deleted when it will not be used anymore. So no headache about when deleted and when is there any memory errors, it will get deleted. So very, very cool concept. There was a question.
Does delete also automatically set T1 to null pointer or not?
Does delete set the T1 pointer to null? I don't think so. All right, yeah, as I said, we will talk about exceptions in a few weeks. Arrays are a bit different, again, also as in C. So we can create it like this. So we can write new integer array, and then we get a pointer back. We can iterate over it, and then we have to delete it like this. But in many cases, you can use vectors, and you don't have to worry about this then. Okay. There is again a short quiz.
Yeah.
About your pets. Okay.
It's just a recap for constructors because it's not that straightforward, and yeah, we want you to practice this so that you fully understand it. And we now want to know which type of constructor is called in each line. Again, we have the pet class, 3 objects, and we want to know in which line which constructor is called.
Okay, few more seconds for you to decide. I think the first one is the easiest one. So the first one, so let's see what you have voted. The first one is a simple constructor. Then the second one is a copy constructor, because we have this assignment. And the third one is, again, a simple constructor. It's not a copy constructor because it's not an existing object we have here. It's just the name. And this is basically, again, the simple constructor we are calling. Okay.
Before we continue with the destructor in more detail, are there any questions to dynamic memory, new and delete? Yeah.
I would have a question, because in C, our use case for dynamic memory is to use it dynamically. And here there is no resize for when you allocate it and you don't give it a size. So it's not really dynamic in my understanding.
We will come to use cases of dynamic memory, I think in the next few slides.
Yeah.
Yeah. And maybe it resolves your question then.
Yeah.
Okay, so destructors, we briefly discussed destructors before, and now we have a use case for destructors and when we use destructors. Again, we had these destructors with this tilde in the beginning, and then it's just the same class name, and we have a body here, which we can do whatever we want. And let's suppose we have a new class called playlist, and we have a vector of song pointers inside. So this is our member, a vector of song pointers. Okay, we have not defined a song, but a song is just another class with some attributes. We don't know, maybe a title. Song would most likely have a title. We can have here a vector of song pointers, and then we have, for example, a method which is called addSong, which takes a title. Then we create a new song here. We call the constructor of the song. So just imagine this is a class with one constructor, and where we set the title of the song. We get back a pointer, a song pointer, and then we push it at the end of our playlist here. So at this vector. So this here is a vector of song pointers that are on the heap. And the cool thing is, when they are declared like this, and I go out of scope of my addSong function, they still remain. So I have them even though this function is over here. And I can work with these songs. I can do whatever I want to do with it, play it, delete it, modify it, I don't know. But at some point, I will delete my playlist maybe. And then the destructor is called. But what I have to do is, I have to get rid of all the memory on the heap. So I iterate with a for each loop over this vector, and I just delete all the songs. This is a very, very classic example of when we need a destructor. In most of the time, not in all cases, but in most of the time, when we use the heap inside of methods, they should be then deleted as soon as the object is deleted. Might be that they are deleted before, but latest when the object is dying, because otherwise we are losing the memory pointer again, because the object is away and we need the object to get to our songs. So when this object dies, so this playlist dies, then I have to delete all the songs.
But now is the question, when is the playlist destroyed? So when does this happen?
That's a good question. It depends, again, on the type. So in most cases, or in many cases, an object is destroyed when the scope ends. You know that when the function ends and we have a local variable, then the object is also destroyed. An object is also destroyed when the memory is freed. Yeah, makes sense. Yeah. Because when I delete my song, when I go back here, when I delete my song here, the destructor of the song gets called. So I could also have some information in the song there, in the destructor of the song there, and work with it. Yes? Can the destructor be empty? I don't think I get the question, to be honest. What? So the playlist is empty. Yeah? Ah, okay. So you mean when you call, for example, songs.clear, which would clear the vector, then the destructor of the song is called, yes? But you would lose in this case the pointers because you have to delete it. Clear does not delete the songs, so remove it from the heap. They will just call the destructor of the songs, but not remove the memory. Yeah, yeah. So just clearing the vector would not work here. So it would work that the vector is empty, but you have memory leaks then. Okay, so we were here at the scope. When the memory is freed, then also the destructor is called. And of course, at the end of the program, which we saw already in the beginning, we implemented a constructor and a destructor, and you saw that the output from the constructor and the destructor is displayed. So at latest, when the program ends, all the destructors from all the objects you created are called.
And yeah, for the sake of completeness, also when a thread ends, an object is destroyed.
But we will not discuss about threads in the first few lectures, maybe in the last one, I don't know, maybe also in the practicals at the end, but this then is, more for the next few semesters. Yeah.
Great, so now we've heard whenever an object is out of scope, it is destroyed. But what are the different types of scope? We have learned about a few in Introduction to Structured Programming, but it's definitely good to recall this, which different types of scope exist. And let's start with the global scope. So whenever we declare a variable outside of any class, outside of any function, it's called a global variable, and we can access this variable anywhere in the program. And as soon as the program ends, this object or variable is then destroyed. So that's one type of scope. Another type is the local scope, which means we define or declare a variable inside a function, inside of a method. In this case here, we declare this variable here in the main function. And in contrast to global variables, whose lifetime ends when the program ends, this local variable here is destroyed when the function or the method is over, doesn't exist anymore. So we have the global and the local scope. Another scope is the block scope. So we can not only have variables in a function, but also within a block, for example, within a function. So we declare this variable here, index is equal to 5, and this means this variable here is only accessible inside of this block here, but not outside here anymore. So not outside of this block in the main function and not outside of the main function.
Looks a bit odd. I don't know when I would use it like this, but imagine having like an if or a for loop or whatever before that, then you have a new scope.
And the object here or the variable is destroyed as soon as we reach the end of the block. Another scope is the class scope. So when we declare a variable inside of the class, it exists for the entire lifetime of object or one object that was created of the class. So this variable then exists as long as the object exists, and when the object is destroyed, also this variable, for instance, a member variable, is then destroyed. And another type of scope is namespace scope. It's quite similar to the global scope, So whenever you declare a variable within a namespace, this variable exists until the end of the program. So you can access it during the program whenever you want, but as soon as the program ends, this variable is destroyed. Are there any questions to the scope? Yes?
I assume that when a class is defined inside a block, it's only accessible with that block. That's why we declared it outside of the main functions. Right? And
Yep.
Even if we have a class that is globally defined, we can still, I guess, make objects that are either in the scope of the current block, or they can be also defined outside of, for example, main to be globally defined. It doesn't make a difference where the class is defined, as long as it is in the same scope as where the object itself is made.
So you're talking about the class definition by itself?
Yes, and the creation of instances of the own objects.
Mm-hmm.
So if we have a class that is locally defined, we can make an object no matter what the scope is.
Yeah.
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 But the object itself will have that scope in which it is defined.
Yes.
Exactly. It's just a variable,
Yeah.
the object that is created, and you can only access the variable depending on the block, or if it is globally declared. Yeah.
Yeah.
So it's just
Usually classes are defined globally, as we had seen it with structs, and then you can use it in every function.
great. Any other questions?
Okay,
Because we
I
then
think that was it from classes.
at least code related.
Yeah, code-related classes.
Yeah.
So we are now done with the basics about classes. We've seen constructors, destructors, copy constructors, and so on, methods, members, a lot of different terminologies. And now we want to just show you another representation of classes, which is UML. UML stands for Unified Modeling Language, and this is just like a standard language to create classes or to make a sketch of classes, for example. Before we code, we can create our own mental model, how we should structure our classes, and then we can move on and code. You will also have to create such an UML diagram, I think, for the second homework. Mm-hmm. And you will also have to create a UML diagram for your assignment 2 as a team. And then we are discussing, or you will discuss with your teammates and then with your tutor, your implementation idea. That's why we want to discuss it in short here. So a UML diagram looks something like this. We have a student class. There are many different representations, but most of the time it's something like this. You have a class name, which is represented like this. You have private members. You have the variable name and the data type. And in this case, private members are declared with this minus symbol. Public members are declared with this plus symbol. This is not a good example because members should always be private. And we have the class name here. As I said, we have member variables declared here, and we have methods here. Of course, this is a very, very small class. You can implement this and writing the code just on your own in a few minutes. But when you have a combination of different classes, let's say you have not only the students, you have the student representatives, you have the universities, so you have many different classes. They somehow work together. You have buildings, you have lecture halls. A student can go into a lecture hall. A lecture hall has a vector of students sitting inside, and so on. So classes are often connected to each other, and then a representation of an UML diagram containing all the classes you want to implement in your program can be very, very helpful to get kind of a mental model what you want to implement. And at assignment 2, you will have to create such an UML diagram for your class structure, and then we discuss together with your tutor if this is a good idea to implement it like this, or if you will have a hard time to implement it like this. And then we will give you hints and tips how to improve your class structure to have an easier life in implementing it. Okay, that was it already from UML diagrams. Yep. We will see a more detailed introduction at the assignment description of homework 2 then. Let's move on to multiple files, and I think this is our last topic then, so works good.
And yeah, let's get back to coding. I'm not sure if we should really code this time, but you will definitely get more in-depth information, details on multiple files, using multiple files in the practicals in the next weeks. Yeah. But let's briefly have a look at it, what it means to have multiple files when you write code in C++. In general, if any one of you has already worked with C++, it will be familiar to you that there are HPP files, so header files, and there are implementation files, CPP files. Usually, if we have some declarations, so it can be any functions here in this case, or any other declarations of variables, we put them into the HPP file. So it's just a separation of declarations and definitions. So we declare the functions add and subtract, and we then define them, so we implement these functions in a CPP file.
Some of you also might did it already in C. Yeah. You can also, of course, create header files, create the structs there you're using, and then just include the header file in the C file. It's completely the same here, except they are called HPP and CPP files.
Exactly. So what happens here is you include this header file here. So in this case, it's OOP1 math.hpp. And what then happens, as soon as you compile it, this code here is copied in this part here. And then you have your declarations on the top and all your definitions below that. So it's basically just a separation of declarations, definitions, makes the code in most cases more readable, especially if you work on larger projects. So you just implement or define the function add here and the function subtract here in the CPP file.
How does this look now with classes?
Very good question. We can, of course, also do it with classes. So yeah, it's good practice to name the file the same as the class name here. So if we have a class pet, we should also name the HPP file, the header file, pet. And we can just declare our class here, declare all of our private members, all of the public functions, so any constructors, any methods we want to use, any destructors, but we do not implement them here really. So this is really just a declaration of these functions, and we can then implement them. So the definitions can then be in the CPP file, so in the implementation file. Again, it's good practice to name this file the same as the class name. And again, we have the include directive here, where we include the header file, and then we can just put the definitions here. So we have to use the class name, then the scope resolution operator, and then we can, for instance, implement our constructor here. Or we can implement another constructor, or the destructor, or any other method.
Why do we need this pet double column here?
Because we are not really inside of the class. So we need to know, or we need to make sure that this is really the method, or the constructor in this case, of the pet class.
So we have to go into the namespace of the class to modify the actual constructor in this case, or the other
or any other methods.
Methods, yes.
Yeah.
Very important.
So if you separate it, you have to use the class name and the scope resolution.
And this is usually the way you will structure your programs. With an HPP file, with a CPP file for the implementation. We will not do it in the lecture because we only have this amount of space here on the slides and it will get too large. But from time to time, maybe we will show it in VS Code, and also the practicals will use this header and CPP files. But this is general the way how classes and implementation of classes are structured.
Are there any questions to header files? Yes.
If we declare a getter that is const, how do I make a definition in the
So if you declare a getter that is const, for instance, like this method here.
Yeah.
So
it's pretty much, as you can see here, this make noise. So you declare it in the HPP, and you have write it const after the function, and in the CPP file, just write pretty much the same, except of adding here the namespace of the pet. But you just write to have const here, and here you have your function body where you can implement.
So a getter would look pretty similar. You would have, for instance, let's take age. It would be int get age const as a declaration in the header file. And then you would add the definition here, which would be int pet scope resolution operator get age const, and then you just return the age. Any other questions?
Yeah, very, very connected to these multiple files are these header guards.
Yeah.
What is this?
Again, we don't have a lot of space here to display code snippets. So it's again a very artificial example. But let's assume we have, for instance, 2 different header files. And let's say this header file here includes this one. And this header file here includes this one. So we have here a few declarations. And here we have a constant variable. If we would now try to compile this, let's say we have a main CPP, which includes this header file here. If we would want to compile and link these files, we would get this error message, which would say, okay, I try to include the header file A in header file B, but if I'm now in header file B, I want to include header file A, and so on. And this, takes place multiple times. And
so you're doing an infinite loop for the compiler.
Exactly, yeah. And at one point, the compiler will say, I don't care anymore. There is an error. In this case, we have a redefinition, and we have too many errors, so I will stop now. Okay, this is unfortunate. There are some cases, of course, this is again artificial, but there are some cases where you will have some circular includes of header files, and where you will maybe encounter the same issue as displayed here. And how can we now solve this problem? We can use header guards. Header guards are actually 3 lines of code in your header file. So when you have a header file, you should always have these 3 files here. The naming convention is actually just the name of the header file. So in this case, OOP1 nav _ HPP. So this is again best practice. They use the same name as the header file for the define here. This means if this part here, so if OOP1 nav HPP is not defined, then define OOP1 nav HPP. Then all the content of the header file goes in there, and at the end we have an end if.
And next time when the compiler is in this infinite loop, it will come to this if not defined OOP1 math, but it knows it is already defined before.
So it just skips this part.
It just skips this part, and we don't have this redefinition problem then.
Yeah. So maybe to improve our explanations a bit more. Once you include, for instance, this header file here, so the OOP1 math HPP, essentially this, or let's say this part here, is copied into this part here. So in this header file here, there's actually include OOP1 pi HPP and int add int subtract, which is here, then const float pi. And then when you have this code in the OOP1 pi HPP file, this then again is copied into this part here where we say include OOP1 pi HPP. So the infinite loop you've mentioned always copies the content of the other header file into this header file, and without header guards, this would result in an infinite loop. And with this header guards, you can then define that this, for instance, OOP1 math header file is already included in the OOP1 pi header file, and then this part is not anymore added or copied, and this is then the reason why this circular include works when using header guards.
So bottom line, use it for every HPP file. This if not defined, defined, and if, and you don't have errors with redefinitions.
Yeah. But please do not use Pragma once, because this is not standard C++. I'm pretty sure you will see it on Stack Overflow or similar platforms, but please use this structure here. So if not defined, define, and if. Again, quite confusing, we know, but really, really important, especially for the practicals.
Yeah.
Any questions to header files and header guards?
I think we are all tired already.
Yeah, 3 hours lecture.
Yeah. It's also hard for us, to be honest, to stand here and talking for 3 hours, but I know also for you to listening for 3 hours. So to sum up in just one slide, we talked about classes and objects, and we talked about constructors and copy constructors, about dynamic memory, and next time we will talk about inheritance. So thanks for being here, and see you next week.
See you next week. Bye.